Welcome to this explainer. Have you ever looked at a super messy, complex situation, or, maybe just a wildly intimidating algebra equation, and just felt an immediate sense of chaos? Well, today, we're going to learn how to bring peace, balance, and order right back to those seemingly unsolvable math problems. Let's dive straight in. We're mastering a really powerful technique that doesn't just help you find an answer, it literally reshapes the problem itself. So here's our roadmap for today. We're going to cover finding order in chaos, look at the 4 steps to solve, and go through example 1, the basics. Then we'll tackle example 2, handling subtraction, followed by previewing advanced math problems, and we'll wrap it all up with education, morality, and peace. Okay, section 1, finding order in chaos. The source material we're looking at today actually introduces an overarching philosophy for this lesson. It references 1 Corinthians to make the point that God is not a God of confusion, but of peace. The text uses this idea to suggest that, hey, whether you're facing personal struggles or a really complex quadratic equation, there's always a way to create order out of that chaos. You absolutely don't have to stay stuck. There is a specific method to restore balance. And in the world of algebra, that specific method for restoring order is called completing the square. You know when our standard factoring tools just totally fail us? Well, completing the square acts as our perfect backup blueprint. It allows us to creatively reshape the problem into something beautiful and, more importantly, solvable. In fields like physics or economics, exact models just don't always fit into easy patterns, right? So this technique teaches adaptability. Instead of giving up because the problem won't factor perfectly, you literally rewrite the equation so you can solve it just by taking simple square roots. Moving on to section 2, the 4 steps to solve. It all comes down to 4 highly reliable steps. Step 1, we take half of our linear coefficient. That's just the number attached to the plain old x, and we square it. Step 2, we add that brand new number to both sides of the equation. Step 3, we factor the newly formed perfect square. And finally, step 4, we solve it. Just like the source suggests we can reshape our lives by finding balance, we're literally reshaping any quadratic equation by finding half that middle number, squaring it, and adding it to balance both sides. All right, let's see this in action in section 3, example 1, the basics. Let's start with a really messy equation. X squared plus 6x equals 7. If you try factoring that directly, you're going to get pretty frustrated pretty fast. Our ultimate goal today is to completely transform that chaos into an orderly, beautiful, perfect square. X plus 3, all squared, equals 16. Just think about how much cleaner that is. So let's build it together. We're going to apply those first 2 steps. We look at the number attached to our x, which is 6. We take half of that middle number, giving us 3. Then we just square it. 3 times 3 equals 9. Boom! This 9 is our magic number. Now for step 2, we take that 9 and we add it to both sides of the equal sign. Why both sides? Well, an equation is like a scale, right? Whatever we do to one side, we absolutely must do to the other to maintain perfect balance. So x squared plus 6x plus 9 equals 7 plus 9, which smoothly simplifies to 16. And this brilliantly illustrates exactly why we added that 9 in the first place. By adding 9, we purposefully engineer the left side to be a perfect square trinomial. Step 3 tells us to factor it. So x squared plus 6x plus 9 instantly collapses down beautifully into x plus 3 all squared. Now on to step 4, we just solve the thing. We take the square root of both sides. The square root of x plus 3 squared is simply x plus 3. And the square root of 16, that's positive or negative 4. We solve for x, and there's our peaceful resolution, x equals 1 or negative 7. We just turned a totally unfactorable mess into 2 clean, exact answers. Let's turn things up a notch with section 4, example 2, handling subtraction. Take a look at this equation, x squared minus 4x equals negative 1. Step 1 asks us to look at the number attached to the x. This time around, it's negative 4. We find half of negative 4, which is negative 2. Now, you got to pay close attention right here. When we square a negative number, what happens? Negative 2 times negative 2 gives us a positive 4. That magic number is always going to be positive. Moving to step 2, adding 4 to both sides instantly restores harmony. We get x squared minus 4x plus 4 on the left and negative 1 plus 4, which is 3, on the right. Now for step 3, we can cleanly factor the left side. Because our middle term was a minus 4x, it factors down into x minus 2 all squared. So our transformed equation is now x minus 2 squared, all equaling 3. So the crucial point here is we just take the square root of both sides to finish the whole thing off. The square root of the left side leaves us with x minus 2. Now the square root of 3 isn't a whole number, but that's okay. We just write it as plus or minus the square root of 3. Finally, we add 2 to both sides, which gives us our final, perfectly precise mathematical answer, x equals 2 plus or minus the square root of 3. Even without neat, tidy whole numbers, we still successfully found the exact solution. Order is officially restored. Now for Section 5, Previewing Advanced Math Problems. Sometimes you're going to see a number right in front of our x squared term. This is what we call a leading coefficient. Take this equation, for instance. 2x squared plus 8x equals 10. Before we can even touch our 4 steps, we have a hard and fast rule. The x squared absolutely must be by itself. But hey, don't panic. If there's a 2 in front, we simply divide the entire equation, every single piece of it, by that number first. 2x squared becomes x squared, 8x becomes 4x, and 10 becomes 5. We're left with x squared plus 4x equals 5. And just like that, we've brought it right back to a familiar, peaceful form, completely ready for us to complete the square exactly like we practiced. The source material actually provides a handful of practice problems. Grab a pencil and paper a little later on and try reshaping these equations totally independently. Just remember the steps. Find half the middle number, square it, add it to both sides, factor it, and solve it. Use your newfound adaptability to track down the solution. Seriously, you're going to be amazed at just how satisfying it is to take something really complex and engineer it into a perfect square. And finally, Section 6, Education, Morality, and Peace. The framework for our source material today actually operates on what it calls the godly learner's philosophy. This specific perspective argues that it's absolutely vital to intertwine education with a foundation of biblical morality. According to the text, intelligence on its own is kind of like an engine without a steering wheel. It argues that being highly educated without this specific moral foundation can actually lead to selfish choices that cause hurt, both to ourselves and to the people around us. The source goes on to suggest that the true goal isn't just getting a high test score, but rather living a well-ordered life. Just as completing the square brings peace to a chaotic equation, the text references Romans 8, stating it promises peace of mind to those who keep their minds spiritual. The author makes the case that focusing on these higher truths alongside our academics is what provides profound purpose and peace amidst all the noise and chaos of the modern world. As we wrap up this explainer, I want to leave you with a quick challenge based on today's text. You now have the actual mathematical tools to systematically solve messy algebra, and you've seen the sophist's philosophical blueprint for a well-ordered life. So how are you going to apply your intellect and your moral compass to the messy challenges you encounter? Will you use them to bring order to the chaos in your own world? Thanks so much for joining me today, and as always, keep learning.